Hello viewers, tutorial 5, question 3b. So the number of hours of daylight on day T of the year for Hamilton is given by h equals 12.1 plus 2.6 times the cosine of 0.0172 times t plus 10. First thing we'll need to work out is how many hours of daylight do you expect there to be on March 23rd. The second thing to work out is on which days of the year there are exactly 10 hours of daylight. So for that question, we're not going to figure out an exact date, we're just going to give an answer something along the lines of, say, the 112th day of the year as our example. So first thing to work out is how many hours of daylight you expect there to be on March 23rd. But in order to get that, we need to figure out which day of the year that is. So we're going to assume that we're not working with a leap year. So January has 31 days, February has 28 days, and we're only interested in the first 23 days of March. Adding those up gives us 82, so we are talking about the 82nd day of the year. So let's substitute that into h equals 12.1 plus 2.6 times the cosine of 0.0172 times t, which is 82, because we just found it was the 82nd day, plus 10. Calculating that, we get 12.09, but that is a decimal, that doesn't say 12 hours and 9 minutes. So it's 12 hours and 0.09 times 60, because there are 60 minutes in an hour, would give us roughly 5 minutes. So it's roughly 12 hours, 5 minutes. Okay, so we've got that we have roughly 12 hours and 5 minutes of daylight on March 23rd. Now part 2, we need to work out on what days of the year there are exactly 10 hours of daylight. So first of all, that is well below the average number of hours of daylight, which would be a little over 12. So we would expect this to be in winter, which would be for us, for New Zealand, that would be roughly mid-year. So we'd expect answers closer to 180 than to the beginning and the end, than say to 0 or to 365. As there are 365 days in the year, we're expecting solutions to be between 0 and 365. Also, I would expect there to be 2 of them, because there would be one solution in the first half of the year as the days are getting shorter, and there would be a second solution after the shortest day when the days are starting to get longer again. So there would be 2 solutions, 2 days in the year where there are 10 hours of daylight. Okay, so the equation we need to solve is capital H, we want to be 10, equals 12.1 plus 2.6 times the cosine of 0.0172 times t plus 10. Okay, so that is what we need to solve. And let's choose our W. So W is going to be what's inside the bracket. W equals 0.0172 times t plus 10. And if we solve that for t, so dividing through by 0.0172 gives W over 0.0172 equals t plus 10. And if we subtract 10 from both sides to get t, we have t is W over 0.0172 minus 10. Okay, so that is our W and our rearrangement. So we'll also need to work out our value of theta, so we'll need to simplify this equation, which means 10, we'll need to subtract 12.1 from both sides, so we get 10 minus 12.1 equals 2.6 times cosine, so we can divide by 2.6 equals cos of W, so therefore W is going to be cosine inverse of 10 minus 12.1 divided by 2.6, and if we calculate that we find that we get an answer of 2.511. Okay, so that's our theta. So now we're ready to draw our table and find our values. So we've got a column for N, we've got a column for W with the working, we've got a column for W with the answer, and we've got T, which is where our rearrangement comes from or comes into play. That's 0.172 minus 10. So for n equals 0, we're only going to worry about the plus solution, because the minus solution would give us a negative value, which would tell us that we'd end up with a value of t which would be negative, and therefore it's telling us a day before the year began, so it would be giving us a solution from the previous year. So say, well, I'm filming this now in 2019, that would give me a solution from 2018. So W of working is going to be 2 times 0 times pi plus, we're only doing plus for 0, 2.511, and this gives us 2.511. If we put that into our value of t, our formula for t, we get 2.511 over 0.0172 minus 10, and that works out to be 136. And for n equals 1, we get 2 times 1 times pi plus 2.511, which would work out to be 8.794. And if we work out the value of t, so 8.794 divided by 0.0172 minus 10 gives us a value of 501. And for the minus solution for n equals 1, we get 2 pi minus 2.511, which is 209. Okay, so this 209 goes in this column. That's the 209th day of the year, but here we would get 3.772. So 2 pi minus 2.511 is 3.772, and 3.772 over 0.0172 minus 10 is 209. So let's decide which solutions are within our required range, which should be the ones that are less than 365, those two. So there are 10 hours of daylight in Hamilton on the 136th day of the year and the 209th day of the year. Very approximately, those correspond to somewhere around mid-May and somewhere around the end of July. Now 501 would be the solution, the main solution from the next year. So I'm filming this in 2019, that would be giving me the May 2020 solution. Okay, thanks for watching, over and out.